Okay, Chem Gang, we're back and we need to look at the third representative sample of the different types of equilibriums. So here it is, and this one's described as mostly products. So we see the 10 reacting molecules of each type, the white and the black, and here's the equilibrium mixture. So once again, take a look at what's there in the mixture. What do you see for the reacting molecules? First, the white molecule, and then the black molecule, and then the product molecules. So what you should have seen here is that this is mostly products. These are all product molecules. There's 9 out of 10 here, and there's only one of each of the unreacted molecules. So what would be the percent yield of this reaction? All right, good. That would be 90% yield because we could have 10 product molecules, but we only got 9. And this is how we represent it in the equation. So this is a reaction where we have a large arrow to the right indicating that most of what's in the bin after the reaction is these product molecules. And there's only one of each of the unreacted reactants. And what we would say about this one is this reaction lies to the right, that the products are favored, or that the forward reaction is favored. And this is related to the fact that the forward reaction occurs more easily than the reverse reaction. So that's how we describe these equilibriums. Now it's time to apply this to the Bronsted Lowry theory. And first of all, this first statement here says that we're only going to be considering Bronsted Lowry reactions that reach equilibrium, and therefore they will lie to the right or lie to the left. And the first point that we want to make from this is that we can actually determine which side the reaction lies to by comparing the strength of the acids on each side of the equation. Remember, in a Bronsted Lowry theory, there's an acid and a base on each side of the equation. And this is how we'll use that information. We'll look at this in more detail down below, but the equilibrium will lie away from the stronger of the two acids. So let's look at an example here. So we have set up a Bronsted Lowry reaction. I left out the arrow because you're going to put that in. So there's two things I need for you to do. First, identify the two acids in this Bronsted Lowry reaction. And now you're going to use your strength chart to predict the nature of the reversibility arrow. So I want you to put the proper type of arrow in here as we had learned on the previous page. So here's our solution. All right. We've already identified, hopefully, the acids as HNO3 and HC2H3O2. So here it's nitric acid and here acetic acid. Note that nitrate can't be an acid because it doesn't have a hydrogen. And the acetate ion is also not an acid. Remember, if the hydrogen is not written out front, it's not going to be ionizable. Right? So there's really only this nitric acid and acetic acid that we would consider. And nitric acid is one of the 6 truly strong acids, so it's certainly going to be stronger than acetic acid here. And that makes the reaction lie to the right. Okay. So at this point, I want you to think about and perhaps write down on the Ed puzzle, why do you think the reaction would lie to the right here? And discuss this in terms of what you know about strong and weak acids and what that means about their nature. So if you read the Ed puzzle solution, a strong acid is a good proton passer. Right? And that means nitric acid is good at passing a proton to acetate to make these products. Right? So that's an example that the forward reaction occurs fairly easily because we've got a good proton passer here. Okay? Meanwhile, the reverse reaction does not occur so easily because acetic acid is a weak acid, meaning it's not a good proton passer. It doesn't easily give up that hydrogen. So it's going to be hard for acetic acid to give the hydrogen to nitrate to make the reaction go in reverse. So that's kind of what's behind the reaction line to the right. We end up with a pile up of the products here because the forward reaction is happening more easily than the reverse reaction. So we've got one final skill in the Bronsted Lowry reactions. And we haven't talked so much about the properties of the bases in the Bronsted Lowry reactions, but it's also important to know that bases can be stronger or weaker as well. And that means they're either good or bad at accepting protons. And this statement right here is important if you take another chemistry class. We're not going to test you on it in this class. But in general, the stronger the acid, the weaker its conjugate base is. And as a direct result of that, we can make a simplification that you will use in today's assignment. And that's that whichever side of the Bronsted-Lowry reaction has the stronger acid, that will also be the stronger of the two bases. So the stronger of the acids and the stronger the bases is always paired on the same side of the reaction. And what that means is we can represent the Bronsted-Lowry reaction by the stronger acid and base on one side and the weaker acid and base on the other side. And remember, the equilibrium will lie away from the stronger acid and, of course, now also the stronger base. Please note that not so good there. That representation is completely equivalent to this one here. All I've done here is write the reaction backwards. So remember, any reversible reaction can be written forwards or backwards. So this and this represent exactly the same thing. Right. There's also an important note here that, again, sometimes we say the strong acid and the weak acid, or the strong base and the weak base. It really should be stronger and weaker. Okay. This only means that this acid here is stronger than this acid over here. It does not have to be one of these strong acids that is truly, quote, strong. And we learned that strong meant 100% ionization. Again, that is not necessary. Only that the base on one side is always stronger than the base on the other. All right. So let's see how you can do this. We've got an example here. All right, another slightly different Bronsted Lowry reaction. And what I want you to do is identify the stronger acid, the stronger base, the weaker acid, and the weaker base on this activity. We'll have you do that on Ed Puzzle. All right, and then you're going to draw in the arrows correctly. All right, so here's your answer. Okay. And again, we really only have two acids here, the nitrous acid and the acetic acid. Again, the acetate, even though it has hydrogens, won't give them away. If it would probably list them in the beginning of the formula. And when you check your chart, you see that nitrous acid is stronger than acetic acid. So that makes nitrous acid the stronger acid, and acetic acid is going to, acetate would therefore be the strong base. Remember, the strong acid and strong base are on the same side of the equation. And then when you have to put in the arrows, they always lie away from the strong acid. So again, here we have a good proton passer and a good proton receiver. So this reaction will occur really easily and make the forward reaction go nicely. However, the reverse reaction is going to have a tough time occurring because you've got a weaker base, a poor acceptor of protons, and a weaker acid or a poor passer of protons. So the reverse reaction is going to have trouble. So we're going to end up piling up the reactants in this case here. All right. So on Ed Puzzle, I'm going to ask you some of the terms that we might use to describe this reaction. So what we should have seen here is that this reaction lies to the right. It favors the products, or it favors the forward reaction. And as I described before, the forward reaction occurs more easily than the reverse reaction. Okay. So it's time for your assignment, if you're actually doing the assignment here. The first thing you're going to do is create an annotated model for this reaction, and that you're going to attach to this assignment. That's what you'll be handing in today. I also want you to complete the acid-base worksheet section on the Bronsted Lowry theory and check the answer key. So you should have all the skills to do that now. I'm always here for questions, and of course, you can ask them on the exit form as well. All right, have a good one, and see you again soon.